Hello, and welcome to the first webinar in the 2020 Virtual Summer Learning Series for secondary mathematics educators from the Department of Education. My name is Robin Conti, and I am the Assistant Director of Teaching and Learning at IDOE. This slide deck is available for you on the Mathematics Standards page at doe.in.gov/standards/mathematics under Professional Learning. Sixth grade teachers can benefit from both elementary and secondary, depending on how your district is set up at the middle level. Today, we will explore an instructional routine by edu-celebrity Steve Wyborney, Esti-Mysteries. Throughout the virtual summer series, we have two purposes. First, we want to explore high-quality math resources that are aligned to the Indiana academic standards to aid in improving teaching and learning of mathematics for all students. What is important to note here is that high quality does not equal complex. Our goal is to explore resources and routines that do not require a heavy lift for educators to implement. Second, we hope that you will discover for the first time or learn ways to refine your current understanding of ways to integrate the specific resource into your instructional routines, both virtually and in person. We've brought our digital learning specialist on to help navigate the remote learning and virtual opportunities. Implementation of an Esti-Mystery is very simple and involves little to no prep. Steve Wyborney is an award-winning educator, author, and the creator of Esti-Mysteries, as well as other great number sense routines. In an Esti-Mystery, students are shown an image and tasked to determine the total number of objects or quantifiable resolution. Students are then given clues to narrow down the possible outcomes. Finally, students are encouraged to justify their choices by determining which of the remaining possibilities are reasonable. A common complaint of math teachers is students' lack of number sense. This helps build number sense in students in a more organic way than a textbook or a box curriculum. Esti-Mysteries have supports built in. Some Esti-Mysteries have a number chart available on the slide presentation as you navigate the task. This is an essential piece to this instructional routine. The visual representation of a number chart helps all students, but especially special populations. Even if a built-in number chart is unavailable, I highly recommend making one available to your students, whether it be by providing a paper or a digital one for independent use, a virtual one through video chat during remote learning, or a large poster in the classroom. Steve Wyborney is working to incorporate number charts on all of his new Esti-Mysteries. In the next section of this slide deck, you will find many links to resources for digital supports. One of my favorites is mathplayground.com. There are many options of number charts to fit an Esti-Mystery. There are colored counters to manipulate to help students visually represent their thinking. Keep this bookmarked, as this may come in handy later in the webinar. Making Math Magic has also created an Esti-Mystery recording sheet you can find in the notes section of this slide deck. This is a great resource to gather formative assessment data to inform your instructional decisions and differentiate groupings in your classroom. Let's try one. Remember the Math Playground website I mentioned earlier? You may want to use that as your 100 chart as we work through this Esti-Mystery. In order for the reveal to work using PowerPoint, you must go to the Slideshow tab and click from Current Slide. If in Google Slide, click Present. You must be in presentation mode for the Esti-Mystery to work correctly. Show your students the picture and ask the initial question: how many packing peanuts are in the vase? Have your students write down their estimate to hold them accountable. I selected this particular one because of the added challenge at the end. Stay tuned to find out what that is. As clues appear, Students will use the information to determine if their answer is reasonable or if they need to adjust their estimation as the possibilities narrow to a smaller set. Students will also have the opportunity to discuss their reasoning and explain their choices as you progress through the clues. The teacher will then go through the clues one by one, giving students ample time to check for reasonableness, discuss the possibilities, and justify their choices. Give it a try. Clue number 1. The answer is between 20 and 90, but is not a multiple of 7. This is where your hundreds chart will come in handy. As you can see, you can quickly cover all of the numbers that are not possibilities, less than 20 and greater than 90, as well as multiples of 7. So you can go through and say 7, 14, 21, so you can click individual as well. Clue number 2. The answer is not a multiple of 5, nor does it include the digit 5. Clue number 3. Eliminate the numbers 39, 48, and 69 since they are not the total. Again, make sure you are giving students ample time between clues to check reasonableness, discuss possibilities, and justify choices. The answer is not a square number, nor is it 2 less than a square number. This is a great opportunity to throw in relevant vocabulary. Maybe you are getting ready to simplify non-perfect square radicals. A quick review of vocabulary can tell you where your students are. Clue number 5. The answer is a composite number with 2 different digits. And clue number 6. This final clue will help you decide if the number is a multiple of 3 and to decide how many of the objects are blue, red, or yellow. There are 2 more blue objects than yellow objects. There is 1 more red than blue. You may choose to omit this clue if you are working with younger students. Otherwise, I love this addition. Now all the clues have been shared and students need to make their final estimation based on the information they've been given. Give students another opportunity to justify their choice. Now it is time to reveal the answer. The anticipation in your class will be palpable. When you click again, the answer will be revealed. The answer is 68 packing peanuts. Were you right? Were your students right? More than likely, not every student will get their answer right, and that's okay. Now is a great time to have meaningful discourse about why. How did they justify their answer? Where was their line of thinking? What were the strategies they used to make the choices they made? If you choose to complete the challenge clues, reveal those next. How did you do? How did your students do? What strategy did students use to determine the number of yellow, blue, and red packing peanuts? This is another great opportunity to talk about solution paths. This was an Esti-Mystery. Your students will be thoroughly engaged and ready for more. On Steve's website, he organizes the tasks by levels. The levels will typically encompass a grade band. This is a great starting point if you're new to Esti-Mysteries. Do not discount lower or higher levels, even if it's outside your grade band. A lower level may be a great way to introduce these to your students, and then you can increase the levels as students gain familiarity. So now you're ready to implement an Esti-Mystery. Here are some great ways to incorporate these into an in-person classroom setting. Use as a warm-up to strengthen number sense, to review new vocabulary. Students are engaged and the tasks are adaptable to any content because they are completely editable. I encourage you to vary these within the progression of your lesson, not only as a warm-up at the beginning of your class, but also as a brain break in the middle of an intense lesson where students may need a break. You're still incorporating standards or skills, but in a more interactive and engaging way. You can also use these at the end of your lesson as a formative assessment to inform your instructional decisions for later lessons. To extend the learning, have students create their own set of clues. You can give students the content or provide a lesson on a new skill and have the students come up with the clues to match the content or objective. Teachers can also modify the clues to adapt to the current objective and skills, or even branch out and create your own Esti-Mystery. By clicking on the bottom box of this slide, you will see how I adapted the original Esti-Mystery to incorporate one systems of equation problem that will result in the same numbers being eliminated. The 5 clues that I will reveal are original to the Esti-Mystery. What I chose to do was show that in less than 5 minutes, I was able to take clue 3. The answer does not include digits 3 or 7, and change it to the answer does not include the values of x and y when you find the solution of the given system of equations. It's a very easy and accessible way to include current content. What about virtually? An easy way to transform learning virtually with Esti-Mysteries is just how I presented it to you through a virtual video conferencing platform like this WebEx or Zoom. Another way is to create a quiz in your learning management system like Canvas or Google Classroom. The teacher could give students a clue each day, and students can respond through the built-in functionality of your LMS. Hyperdocs are becoming more popular. Teachers can create a digital document such as a Google Doc that incorporate hyperlinks to all the resources students need to complete the tasks. In our example, students can type in their responses and utilize the virtual manipulatives and a number chart to help synthesize the information and inform their choices. You could leave the answer for the students to reveal themselves or even remove it completely. After they turn it in, you could send them the reveal. My favorite way to transform an Esti-Mystery is by Google Form. Much like the other ways, students navigate through the tasks in a similar fashion. They see the image and are asked to make an initial estimate. As they submit their answer, students get the first clue and continue revising their answer. After some choices are made, students will begin to see a visual representation of the eliminated numbers and the possibilities still left. Students can now adjust their estimation and continue the task. Students are prompted to make their final estimation and justification. They are then given the reveal and can check their work. The great thing about this is after they submit their work, you have access to all the data. What a great way to learn about your students' understanding and to inform your teaching. This would be a great follow-up in a virtual setting if you choose a live version for students that were unable to join the live class, still be involved in the lesson. One could argue that each and every process standard is embedded in an Esti-Mystery, but there are some standouts. From reasoning and explaining, process standard 2, reason abstractly and quantitatively. Mathematically proficient students make sense of quantities and their relationships and problem situations. Esti-Mysteries may throw in a curveball in the form of a die, domino, mirror, or bingo ball. These are not always relevant, so students are required to make sense of the information as they navigate the task. Process Standard 3. Construct viable arguments and critique the reasoning of others. Mathematically proficient students understand and use stated assumptions, definitions, and previously established results in constructing arguments. They make conjectures and build a logical progression of statements to explore the truth of their conjectures. They organize their mathematical thinking, justify their conclusions, and communicate them to others. Mathematically proficient students participate and collaborate in a mathematics community. Esti-Mysteries build students' ability to argue and reason proficiently. These tasks are accessible, lowering the floor for many students so they feel comfortable in joining the conversation. They listen or read the arguments of others, decide whether they make sense, and ask useful questions to clarify or improve the arguments. From Habits of Mind of a Productive Struggle Mathematical Thinker. Process Standard 1. Make sense of problems and persevere to solve them. Mathematically proficient students analyze givens, constraints, relationships, and goals. They continually ask themselves, does this make sense and is my answer reasonable? Process Standard 6. Attend to precision. Mathematically proficient students communicate precisely with others. They use correct mathematical language in discussion and in their own reasoning. Indiana academic standards will change for every Esti-Mystery depending on the content it covers. For the one we tried today, we have begun to address the following standards. For NS8, find all factor pairs for a whole number in the range 1 to 100. Recognize multiple of its factors. Determine whether a given whole number in the range of 1 to 100 is a multiple of a given one-digit number. 6 and S6, identify and explain prime and composite numbers. 7 and S2, understand the inverse relationship between squaring and finding the square root of a perfect square whole number. Find square roots of perfect square whole numbers. And 8, C1, solve real-world problems with rational numbers by using multiple operations. If you choose to explore the challenge, you will also address 8AF1, solve linear equations and inequalities with rational number coefficients fluently. 6AF3, define and use multiple variables when writing expressions to represent real-world and other mathematical problems. And even Algebra 2, F1, understand composition of functions and combine functions by composition. A great resource to help you with this is the Math Framework. The Math Framework offers a looking back and looking ahead section that shows you the vertical alignment of standards. Utilizing this part of the framework can help you choose tasks that best fit your students' needs. Just like the process standards, one could argue all of the NCTM 8 effective teaching practices are embedded within an Esti-Mystery. There are some that are more significant for this task. Implement tasks that promote reasoning and problem solving. Students are continually being asked to adjust their answer as they navigate the task as new information is presented to inform their choices. Facilitate meaningful mathematical discourse. Esti-Mysteries promote students talking through their choices and possibilities, which strengthens their ability to justify their answers. Pose purposeful questions. The teacher can adjust the clues to introduce relevant content and develop intentional questions around that content to help them inform their instruction. Elicit and use evidence of student thinking. Esti-Mysteries are a useful tool for formative assessment. Student responses can offer valuable information about what a student knows or does not know. So why an Esti-Mystery? These tasks help engage students in the content and make sense of their estimations rather than just guessing. Requiring students to justify what they know will help them be able to justify something they don't know. Esti-Mysteries are a great number routine and one of the easiest ones to implement. Be mindful that number routine should be an integral part of your math class. It should not be something fun and that you only do when you have extra time. Copyright gives exclusive rights to the original work. Any work that is copyrighted is owned by a specific person and you must gain permission to use the work. Educational fair use is an exception. It provides limitations without seeking permission from the copyright. Teaching falls under the educational fair use. In its simplest form, you can use work that is copyrighted as long as it is not for profit or commercial use, is suitably appropriate, the work stays intact and original to its use, and its intended use will not affect the copyrighted material's value. This does not discount credit. You must still source and give credit where it is due. For example, this flowchart was adapted with permission from art class with LMJ. She created an educational fair use flowchart that I wanted to adapt to support math teachers, so I reached out to her and was given permission by her to adapt and use the resources in this way, but I'm giving her credit by linking the source in my document. Use the flowchart to figure out what path to take when using work from outside sources. Some basic rules of thumb include: if you did not personally create it, assume that it's copyrighted. If your use of the work will result in profit, distribution, or personal gain, you should always get permission first. If the work is not being used outside of class, you are typically safe, but it's always best to have the original sources cited and available. Thank you so much for joining me today. You can scan the QR code by opening your iPhone camera and holding it up to the screen or another QR reader app. You can also click the Here on this slide to fill out a short survey. My contact information is also available. Feel free to email me or tweet at me anytime. I'd be happy to help. Thank you so much for your time and your dedication to Indiana students.